Hi there, Year 11 IB. Today we're looking at rational exponents, 3C. Remember, rational meaning fractions, so that means we have a fraction in our exponent. Hopefully you remember from Year 10 that if we have to the power of a half, we're talking about the square root of A. The power of the third, you may have remembered that or may not have come across it. That means we've got the cube root of A. In fact, A to the 1 over n means the nth root of A. So we can combine that with our normal powers, our integral powers. So we have m over n for our exponent. Then that means we've got the m, that's the root, the power of m for A, base A, and the n refers to the root, so we have the nth root of A. And it doesn't matter whether we take the nth root first and then raise it to the power of m, or whether we do the power of m first and take the nth root. It's both the same. So in other words, that's saying A to the 2/3 is the cube root of 8 squared, which is the same as saying the cube root of 8 all squared. Now, I'd rather take the cube root of 8 first than square the 8 first, because I know the cube root of 8 is 2, and now I just can go 2 squared, and then that gives me 4. Make sure you can do that on your calculator. Look to see where you can do the indices and then use your fraction button as part of the indices. So you can stop and pause that now and test that on your calculator. So use your calculator to calculate these ones, and then stop, pause it, and then come back and check your answers. So check your answers to see if you got those using your calculator. Remember, if you have a squared, the square root of a, times the square root of a, that equals a, because a to the half times a to the half will be a to the 1. It's the same with the cube root, so that means we've got a to the 1/3 plus 1/3 plus 1/3. So we can multiply with the same base. You're adding exponents. A to the 1, which is a. And it doesn't matter which way we write that, in that cube root notation, you get the same. So you should hopefully recognize that and remember that. So let's run through just a couple of examples here. In 3C, question 1, you want to write this as a single power of 2. So let's do part C of this. So this is the same as 2 to the 1 times 2 to the half. If we want a single power of 2, then we're putting 1 and a half together to make 1 and a half. And we usually write that as improper fractions. So you're going to have to get used to fractions again. Hopefully you're good at them. If not, you need to practice so that you are good at these. In question 3, we need to write this in the form a to the x, where a is a prime number and x is rational. So at the moment in part B, 27 is not prime, so we need to turn that into a prime power. And we should mostly recognise that as 3 cubed. So therefore this is the same as 3 to the 3/4. The 4th root is the quarter part, 3 cubed, the cubed is the top part. In H, we can start off by turning that into 16 to the -1/5, because we've got the 5th root, and it's in the denominator, so that's the minus, so it's -1/5. Now we can recognise that 16 is the same as 2 to the 4th, to the -1/5. We multiply exponents, and we shift this down to make a bit more space. So So we end up with 2 to the minus 4/5. So just get used to working with exponents and converting them. The next part, you're going to use your calculator again. So check using your GDC for the answer to 2b, 4b and 4c, making sure you can put those negative exponents in. So pause the video and then come and see what you get. Hopefully you've come out with those 2 answers. Remember, in a calculator paper, you always round into 3 significant figures for each of these. That's the usual rule for paper 2. In the next part, you need to do this without a calculator and writing these in the simplest rational form. So we need to use the exponents, and you're going to do part B. Think, well, if I want 8 to the 5 on 3, and I can recognise that if I want the cube root of 8, I can do that. And I always like going smaller numbers first, then bigger, because otherwise, to make the power of the 5, you're not going to be able to do that without a calculator. And I always like to try and do as much as I can without the calculator, as well as being able to do it with. So I'm going to do the cube root of 8, and then raise it to the power of 5. So I get 2 to the 5th, which is 32. All right, these other ones, just remember to take, let's do this one as well. Negative exponent. So we've got 9 to the minus 3 over 2. Doesn't matter what order you want to take that in. I'm going to take the square root of 9 and then have it to the power of minus 3. So 3 to the power of minus 3. 3 cubed is 27. So it's 1 over 27. All right. This part on the theory of knowledge, we're going to actually talk about that in class and look at how we can talk about that whole thing, concept of proving and how do we prove something, or can we not prove it, or can we, and do we believe it if we can't prove it. Anyway, we'll leave it for there now and see you in class.